you are asked to determine the specific latent heat of fusion L of ice using the method of mixture. You are provided with the copper calorimeter, 3 thermometers. You have to select the most appropriate one. Water at room temperature, block of ice at 0 degrees, and filter paper. Part A. What are the other measuring instruments and items that you need to do this experiment? Then during the experiment, I will describe that how to do the experiment. When using mixing method to find the latent heat of fusion, we have to get a calorimeter and we have to pour water up to about 2/3 of its height, and we have to measure the initial temperature by using the thermometer. Then we can put ice cubes one by one, and we can stir to dissolve ice in water, and we can get the minimum temperature. We can obtain by dissolving ice. We have to consider the heat absorbed by water and calorimeter should be equal to heat emitted by ice. But in this process, there are two methods of heat absorbed by ice should be equal to heat emitted by calorimeter and water. When considering heat exchange of ice, there are two methods to convert solid ice to liquid state. It is the type of MS, and after dissolving ice, it makes water at 0 degrees. After getting 0 degrees water, it should be increase the temperature of water up to minimum temperature obtained by the practitioner. Therefore, there is a heat energy in type MS theta. There are two methods of heat absorption by the ice. But we have to consider, we have to get the minimum temperature such that there is no dew around the calorimeter. If it passes dew point, when reducing temperature, if it passes dew point of the system, our calculation is not correct. It is the practical. Now we know that when getting MS theta, we have to measure mass. Therefore, we have to use the balance to measure the mass. The most suitable balance is an electronic balance. But we can write triple beam balance, 4 beam balance, or chemical balance. When writing the suitable measuring instrument, we have to write the balance type. It is compulsory. If you are written as balance, they will not give marks for you. You have to write balance type. Most suitable balance type is electronic balance. In part B, it is advisable to determine the dew point of atmosphere approximately before adding ice. What is the reason for this? When conducting practical, we have to maintain the minimum temperature. The minimum temperature of system such that it is greater than dew point. Then part C, parts of the enlarged scales and their range of 3 thermometers PQR available in the laboratory are shown in the figure. There are 3 types of thermometers, P, Q and R. The range of P -10 to 60, Q is -10 to 110, range of R is -10 to 250. Part 1, if the room temperature is 30 degrees and dew point of air is 24 degrees, select the most appropriate thermometer that should be used in perform this experiment. We have to use P thermometer. C part 1. We have to use P thermometer. What is the least count of the thermometer selected in part C1 above? We can use the given scale to find the least count. They have marked 30, 31. Between 30 and 31 degrees, there are 5 parts. 30, between 30 and 31, there are 5 parts, like this. It means this value is 30, this value 30.2, 30.4, 30.6, 30.8, 31. Therefore, least count is 0.2 degrees Celsius. When selecting suitable thermometer, we have to consider the sensitivity. We can consider least count when getting sensitivity. The minimum least count is for the P thermometer. Therefore, we have to use P thermometer as a suitable thermometer. In Q and R thermometer, the range is a long value, -10 to 110 and -10 to 250. But it is not useful for the experiment because of they have given that room temperature is 30 degrees, dew point of system is 24 degrees. Therefore, we have to do the practical between the temperatures 30 and 24. Therefore, we have to measure only temperatures between 30 and 24. Therefore, it is not useful to use a long range. But we have to use the thermometer with maximum sensitivity. The maximum sensitivity is for P thermometer because of the least count is the minimum value for the P thermometer. In part 3, what should be the initial temperature of the water? When doing this experiment, we have to consider that there is no heat exchange between environment and system. Therefore, we have to do a correction for heat loss. Therefore, we can start the practical. The room temperature is 30 degrees. They have given that and dew point is 24. We can't get the minimum reading after dew point. It means we have to maintain the minimum temperature of the system such that it is greater than 24. Therefore, most suitable minimum temperature we should get is 24.5 Celsius. Or you can write 25, but most suitable value is 24.5. Now, the difference 24.5, or you can get, but when measuring 24.5, it is difficult to use this thermometer. This count is 0.2, therefore we can get 0.5, 0.2, 0.4, 0.6 are the measurements we can get by this thermometer, therefore we have to write 25 degrees. It is the least temperature of the system, and the maximum temperature should be 35 degrees. It means we have to increase the temperature of the system up to 35, and then we can continue the practical. We can mix ice cubes one by one, and we can measure the minimum temperature obtained when adding ice mass. By this method, we know that for this part, the temperature of the system is greater than room temperature. Therefore, there is a heat loss. For this part, the temperature of the system is less than room temperature. Therefore, there is a heat gain. We can get that heat loss for this temperature range is equal to the heat absorption for this temperature range. Therefore, when conducting practical, we can consider that there is no an effective heat energy loss or absorption with the temperature. It means there is no heat exchange with the temperature. Therefore, most suitable maximum value of temperature is 35 degrees Celsius. This is the answer for part 3. Then part D, when preparing ice, adding ice into water and mixing ice, what steps would you take to ensure proper procedure in order to determine S? When preparing ice, we have to get dry ice. It means dry ice and small ice cubes. When getting dry ice, they have given filter papers. We can use filter papers to remove liquid water in ice surface. Then we can write part D, when preparing ice, remove liquid water on ice surface by using filter papers, and get small ice cubes. If we are getting a large cube of ice, we can't control this temperature. It will reduce the temperature after the dew point. Then, when mixing ice, we have to consider, we have to mix ice such that the water drops, the water will not remove from the container. Mix ice such that water will not be removed from the container. Then last one, mixing ice. When mixing ice, we have to mix ice is water such that the ice cube is always in water by using a stirrer with a net. We have to use, we know that when ice is put into the water, ice will not immersed fully. It will floating. It will be floating on water surface. Therefore, we have to use the stirrer with the net to mix ice and water such that ice is immersed in water. Then part E. 1. What are the temperature measurements that you would expect to take this experiment? Give them in order to measurements. First of all, we have to measure the initial temperature of water in calorimeter. It means it is approximately 35 degrees. We have to select 35. Initial temperature of water. As the final temperature, we have to get minimum temperature of the system. Minimum temperature of the system of water when dissolved in ice in water. Then part 2, in order to measure the second temperature mentioned in part E1 above accurately, you could plot the variation of temperature theta of water with time t. Sketch the curve that you would expect using the given axis. We know that when mixing ice, the temperature will decrease with time, and when mixing ice without and again ice to the system, there is a minimum temperature, and after that it is increasing temperature again to the room temperature. Therefore, graph should be like this. Initial temperature is greater than room temperature, it is like 35, and final temperature should be room temperature. It is there is an equilibrium with room for the final situation. In part F, apart from the temperature measurements mentioned in part E1 above and the liquid masses with liquid mass measurement, what data would you need to determine latent heat L? In calculating latent heat, we have to use specific heat capacity of the water and specific heat capacity of calorimeter. Then you can write part F1, specific heat capacity of water, and we can write second data we have to need, specific heat capacity of copper. They have given that it is a copper calorimeter. Therefore, we have to use specific heat capacity of copper. Part G, if the added ice contained water at 0 degree, with it, would you expect the value will be higher or lower than the standard value? We know that when adding ice cubes, if there is a water mass with ice, the mixed ice mass is less than our reading, because of when mixing we have mixed ice with water. Then our calculated ml value. When considering ml value, when m increases, L should be decreases. Therefore, we can write G part 1 lower. Give reasons for your answer. When water is mixing with ice, mass measurement of ice is greater than actual ice mass.